exempt.
What?
No,
Yours in government, and I do pre-cal.
Maybe my only one on Friday.
I'd exempt government and pre-cal, and this, and just do pre-cal.
All
right.
Well, there's a reason we can't. I mean, it's because it's not weighted. Like, this is not worth.
I don't care.
Oh, yeah.
No, it's worth like 5% or something.
All right. So, if you guys can get out, you forgot your notes. Oh.
Man, I forgot my bag, so I mean, this is great.
All right. So, we are going to talk about power, yes.
Oh, wait, I want to test this out.
Are we going to be covering heat and transferring heat? And converting energy to kinetic energy
In this chapter,
you need a PSA grade out of 10. Perfect. Ooh, that's like that's a solid.
That's solid right there.
I think Mr. Ballard
not
like this school.
No.
Honestly, I have no idea why I said that.
All right. So, let's see what we got. Make sure you guys can read all this. That's pretty good. Okay, so we are going to skip a few problems. If you want to do those practice problems, you can. I can check those. But we are going to move on to work or power. Power. Am I on the right one? We already did all work.
I mean, if you want to do work,
That's just silly.
extra.
That's just too much extra work.
wow, you stole my joke.
Have you ever seen the Key and Peele where he steals the joke? It's really funny. Have you ever seen Key and Peele?
Yeah.
I've seen a couple,
Man.
We gotta play.
but the one that I seen was not so appropriate.
It's really funny.
It was the auction block one. Anyone seen
The
that?
substitute teacher.
Yeah.
Hey,
Oh my god!
hey, Ron.
Can we play?
Please.
There's the one where he like.
D nice.
Okay, here. Let's hurry up and get this done so we can watch that.
All right. So power is the rate at which work is done. So we know how to calculate power. The only difference in this is we know how to calculate work. We're taking work divided by time. Okay. Now there is a conversion. I'm not going to use it up. I don't know. I put it up here just so you know. 1 horsepower is equal to 746 watts.
Power.
Is that how much one horse can withstand?
I mean, yeah.
Withstand? Like until it dies, or like?
Probably.
Okay.
Whoa. So you're saying that
One
horsepower is 746 watts?
Correct.
Then my computer has 1.34 horsepower.
There you go.
That's pretty fast.
That's pretty good.
It doesn't move.
That's pretty good. All right. So that is.
Wait, so then how much power does Kanye West song Power have, guys?
It probably not a lot,
Probably 0.
but it does have some pretty good days
All right.
in there.
So if we look at an example, example number 18, it says an electric motor lifts an elevator 9 meters in 15 seconds by exerting an upward force of 12,000 newtons. What power does the motor produce in watts and horsepower? Okay, so, does anybody remember my work equation?
Force times X times cosine of something.
Force times X times the cosine of theta. Okay, so an electric motor lifts an elevator. Well, it lifts an elevator, and the elevator is going up. So what's our angle? 0. They're both going up. All right, so I have cosine of 0 times the displacement is 9 times the amount of force, which is given as 12,000. All right. So what's that give us? What's that?
108,000.
108,000.
That's a good number.
Okay. Now that is work. What is power?
Work divided by time.
Power is work divided by time. Okay. So what you're going to do, let me zoom in a little bit. What you're going to do is you're going to take that number, divide it by, what's our time? 15 seconds? And I got about 7,200 as my final answer.
That is exactly correct.
And the unit for power is watts. Okay.
Wait, Glenn, you're not gonna talk about supervision?
Nah, I'm too tired to really care today, honestly.
I was like, that is the correct
I
answer.
was like, wait.
Yes.
Okay. For cosine of theta, did you set theta to 90 or 0?
0.
Okay. And also, the motor wouldn't exert all of that power because elevators have counterweights.
Oh my
They're
goodness.
same as the elevator, so it actually only carry the people inside it.
Yes.
Fair enough. Have you ever seen Inception?
I thought you were about to hit him with that. I was
Think
waiting.
about it.
I saw you were like.
So there's a scene where in the movie where they lose gravity. It's really, really impressive, actually. And then it's probably the second most physics related movie, involved movie I've seen. And the first one is Tenet.
Oh, not Bill Nye.
It's a newer movie. I wouldn't recommend. I'm not recommending it.
I saw it.
It's a good movie, and very physics related, but not really school related.
How was
that
it?
the movie where
Okay,
they
like-
a single green screen, like it was all filmed like natural?
Yeah, I'm
How
pretty
was
sure.
okay?
Pretty sure that's the one.
I want to know like how
What's it
it relates to physics.
I watched the movie and I don't even know what it was about. It was so confusing.
Yeah, but brilliant.
How was it related to physics?
We'll get there.
Okay, I just want to know.
Maybe.
Now you piqued
All
my
right.
interest.
So, if we look at this next one. To pass a slow-moving truck, you need 1,300 kilogram car to accelerate 13.4 meters per second to 17.4 meters per second in 3 seconds. Now, what's power equal to? So power is equal to work over time. What is work equal to?
Force. Distance.
Displacement.
Force times
Cosine of
displacement times
Cosine
cosine of theta. Now, this information, are we able to use any of that?
No.
Not a whole lot. So what's our second equation
Oh,
for work?
For Newton's.
Mass.
Mass.
Oh, a little louder.
Kinetic energy.
The change in kinetic energy. So what we're going to do is we're going to see the change in kinetic energy.
Are you sure you're making that?
Me? No?
No.
I was like, holy smokes. I mean, we don't have to do this. So, now what's my kinetic energy equation?
1/2
Mass.
times
Velocity final squared. So minus 1/2 mass times initial velocity squared. Okay? And then don't forget our divided by t.
Oh, see now this makes it easy.
Now, can we plug in our data in this equation?
Yeah.
Should be able to. Should be able to. Half the mass. Our mass is 1,300 times the final velocity, which is 17.9 squared. All right, and then minus 1/2 the mass times the initial velocity, 13.4 squared. Okay, all divided by the time, which is 3 seconds.
That's a lot.
It's not that bad.
Because of what?
I just said it was easy.
Hey, didn't say it was hard. I said it was a lot.
Some of the things we've done.
Wait a second.
30,000 is what I got.
Actually, that's a pretty heavy one.
I got 30,000 as well. Is that what you guys are getting?
Hold on.
So as you can see, work and power are very, very similar. Just power has work divided by time.
So you got that equal 30,000 watts.
Yeah,
2,860.
It's just like a-
not too bad. Any questions on that?
It's just like-
All right, let's try. I want you guys to actually, let's try 20 on your own.
That's it.
Try 20 on your own real quick.
It's on
It is on a hill.
Wait, what was the answer for the last one?
30,000.
Perfect.
All right, we're starting to use everything that we've learned in the next two chapters. Or the next two, yeah, honestly, but the next two problems. Next two problems. If you have to communicate with a friend, that's fine. That's fine. Requires a little critical thinking. Takes a force of 1,280 newtons to keep a 1,500 kilogram car moving with a constant speed up a slope of 5 degrees.
That means that acceleration 0.
If the engine delivers 3,300, what is the speed of the car? I should say, what is the velocity of the car?
Is it negative?
I should say, what is the velocity?
Mass times. I think he's in. Right?
Is the car moving initially?
Initially wouldn't have been 0.
No?
We don't really need to know that.
Are we taking into account momentum?
Nope. So let's start off going in the right direction. All right. Let's start off going in the right direction. So, what's my power equation?
Technically. Oh wait, what? What? Wrong one.
Work over time.
We can't see.
I don't want you to do on that. I'm just kidding. Power is equal to work over time. Okay. What's my work equation?
Once you write it out, it's like, oh yeah.
All right. So I'm trying to find the speed, correct?
Oh my goodness.
What is that right there?
Are you kidding me?
Yeah. What's the velocity equation?
Displacement over
Distance
time.
Displacement.
Displacement over time.
Oh.
So all we need is a displacement.
So power is equal to force times the velocity times the cosine of theta. Okay.
So you're,
I'm never gonna remember this.
so instead of having it over time, you can just do force times velocity.
I do this. We know what the force and
Wait, Steve?
Whoa, that's all. That's actually pretty cool.
yeah, that's 29.
All right. So what you can do is force is 1280 is equal to power, which is 37,300 times velocity times what's my angle? Okay, solve for B. 37,300. I got 29 point, well, 3 sig figs, 29.3. How do you guys feel on that one?
See, now that I would have never gotten that, but
AP exam is going to throw questions like that. It's going to be tricky. All right.
Mr. Rouse,
Yes,
can I ask a question about sig figs?
absolutely.
So I got 29.25.
Yep.
So it says on the rules running that equals pi we round up to an even number.
I got 29.251937, so I got something a little above that.
Yeah, I got that too. So when do you use that equals pi?
Oh, that is a great question. So when you will use that is, let's say, what will, hold on, I want to make sure I give you a good example. Nope. Man, let me think of a good example. Give me a second.
wonderful weather we're having, isn't it, guys?
We can't see it. Hey, it's E A T squared.
Oh, wow.
What's going on? What's the displacement?
Okay.
Oh, it's half.
This type of problem, if you see this, okay, it's a division. So your answer is going to be not your final answer, but the answer to this division problem is 20.5. 20 and a half. Now, since there's nothing after this, right? There's nothing after that. What I got to see is I got to round to 2 sig figs. All right, so these are my 2 sig figs I'm focused on. All right. And then I got to look at the next one. Now, since it's just a 0.5, that's when that rule comes into play. So 0.5, I have to round to the even number. So it's going to go down to 20. And that's when you apply that rounding rule.
Thank you.
Now, if it was anything, like if I had 0.501, then it's going to go up to 21. Yes.
So why does it round down to 20?
You have to ask the Albert Einsteins for that.
He's dead.
I don't
His
know.
brain got stolen. Did you guys know that?
I have no idea.
Today?
No, he
Oh.
died.
His brain got stolen? Oh, I did know that.
Yeah.
I have heard that.
I think they
So, you'll
analyzed
never
it
find out.
first, but
We'll never find out.
His brain wasn't that much. I don't even think his brain was bigger.
no, they analyzed it. There's just a ton of
All right.
connections. Where
Now, the last power problem. All right. You guys might see a problem like this. Another one you'll probably see similar to on your AP exam. This looks simple. And I'm not gonna lie to you. This one's gonna take a minute. Try it out.
I feel like I did it wrong now.
Try it out. A man lifts a 10-kilogram box 3 meters above his head with 150 newtons of force. How much power? How much power?
So if he's going straight up.
He's going straight up.
He lifts it 9 feet.
So is that 90 degrees?
That's the same thing, but when that's long arms, right?
So he's lifting up,
So
and the box is going up.
so 0.
So 0.
That's okay. Wait, we don't have time.
We don't have time.
Is there a little bit of a throwback?
It is a throwback. You might need your little green equation sheet out. Might help out.
Oh, I'm doing something new, maybe.
So displacement.
Dang, it's been.
Oh, and we're doing the time of the present.
F equals MA.
Oh,
It's been a minute.
that's a possibility. I'm sorry. You sound like there's gonna be a joke.
Say what?
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 You said there's no time for the president to get off the equation sheet. And the way he said it made it sound like he was trying to say a joke.
Ah.
It's funny.
So wouldn't the acceleration be gravity? Like gravity's acceleration?
The gravity is the accelerator.
So negative.
In the y direction.
In the y direction, so would that be negative?
Wait a second. No.
So force of gravity, you're gonna just get a total of 98.
I didn't even use gravity.
But so you have the force of gravity going down and his force going up. So gravity would be like, you're gonna have 150 up minus the force of gravity, which is the 98 pulling down.
Oh, I see.
So the force of gravity.
So F equals.
I already know you're the same
right? So 150.
I never included gravity. I got an answer. I think might be right. Still.
Okay, so that's
If you got it done this fast,
Displacement.
Well, I was working on it before.
then maybe. I mean,
Because for acceleration, I just use the distance equals mass times acceleration.
But we don't have time. How do we figure out acceleration?
Oh wait, did I just? So the force.
Not someone computer.
So you have that force. The force counteracting it is gravity. So you gotta find the force of gravity on the object and subtract those two. Okay.
Okay. Yeah, I don't know how you find it, but. Wait, A
Ooh,
equals.
there's a
Is it 600 watts?
How do you find time?
I did say things.
you're within 191.
So add or subtract, you got a 50% chance. Okay. The only thing that I'm having trouble with is trying to find the
Oh my
time.
gosh!
Time
Throw together.
is the trouble.
Ah,
So
Yes.
let's walk through this
So
one.
that I didn't.
I'm gonna cry when I see the AP
I'm
exam.
not smart.
So I'm just gonna get started on a blank sheet.
Alright, I got 4.
Okay, are you guys ready?
Yes, just work us through this.
Power is equal to
Work over.
work over time. Work is equal to the
Force
force applied times the displacement of displacement times the cosine of theta over time. Right? Let's see, the force applied is 150. The displacement is 3, and the cosine of 0 all over time. Okay.
Wait, why is it 150 and not 52?
Is there something in
Is mine wrong?
Because you do 150 minus, so that's the force applied minus the force of gravity.
Right.
So
We're just finding the force applied right now.
okay.
To find the work applied. So right now I have 450 over time. Okay. Time is very valuable. Alright.
Wasted.
Yeah, let's, just like, honestly, time is money. Like, I haven't, like, I've heard that, but this year has really hit me how much, like, time is money and how valuable it is. It's pretty impressive. All right, so time. What do we know? We know we're trying to solve for time. We know that the displacement is 3. We know that the initial velocity on the box is 0. Okay. We need one other factor. And the other factor we can solve based on the data given to us is acceleration. Okay? So, if we're trying to solve for acceleration, here's my box. There's a force of gravity pulling down on it, but I'm applying a force applied on top. All right? So what you're going to actually have is the sum of forces in the y direction is equal to mass times acceleration. Is everybody following so far?
Yeah.
Okay, so I have a force applied. He applied 150 newtons. Gravity is going the opposite direction, so 98. So I'm going to write it out if that's all right. So you have mass times the acceleration due to gravity, all right, is equal to the mass, which is still 10. Make sure I'm doing mass times acceleration. Does that part make sense? So once you solve for acceleration, I got acceleration to be 5. Okay, so this is using last chapter of Newton. Now we're going back to the acceleration. What equation am I going to use? What equation am I going to use? X equals initial, well, I should say delta X, is equal to initial velocity times time plus 1/2 the acceleration times squared. All right, so delta X is 3. What's my initial velocity? 0. So I can just get rid of that. Half the acceleration t squared. So what's my time? So 1.1?
Yeah.
I mean, I'm just rounding. You can do 1.07 if you want. So what you're going to do is you're going to take that time. Plug it in up there. So my answer, I got 2 sig figs, 410. Yes, Keegan.
Why did you use sig fig rounding when you got acceleration but not for time?
What was the final answer here?
5.2.
I could keep 5.2. You can, theoretically, you have to keep everything that comes up in your calculator. I just don't plug it in my calculator. I just heard somebody say 5.
How do you write that down on an AP exam? Would you just do write down every single one of the digits that shows up on your calculator?
You wouldn't have to.
Or do you just show the algebraic value, just
The algebraic, yeah. Yeah. So really what it looks like, let me see if I can do it on the calculator. Yeah. Okay, so you have 150 minus 10 times 9.8. Divide that by 10, so you got 5.2 times 0.5. All right, so you have 3 divided by that answer. Take the, see, like I'm keeping all the decimals. Take that answer, take the square root of it. Does that kind of make sense?
Yeah.
And then, honestly, you're going to take that entire thing and plug that up into the work. So 450 divided by that entire answer. So you got to use the I don't know what it's called, the answer function, the previous answer function on your calculator, decent enough. So my answer I got is 418, so 420.
Can we watch the substitute teacher now?
So what?
Can we watch substitute teacher now?
That was a decent amount. Let's relax a little bit.
Yeah.
That was a real brain doozy.
Hey, Owen.
We did good.
Okay.
I hate
The
to
one where they-
rewatch.
It's never relaxed. My secret is my memory.